Welcome. We are now on page 2 of the Chapter 9 exam practice, and our two problems on this page will be examples of dependent samples from two populations, also called matched pairs. So let's take a look at number 3. A coach would like to see if there is evidence that a new training technique can help improve the scores of gymnasts. 7 gymnasts were randomly selected to participate in the coach's study. Their competition scores were recorded before and after completing training with the new technique. The matched pair results are shown below. We'll use a 1% significance level to test the claim. So as always, we're looking for claims. So we'll be testing the claim that the new training technique on average is effective in raising gymnasts' scores. And we'll assume that distribution of differences is normally distributed. That is just a requirement in order for us to proceed. All right, so we will let, for these matched pairs, we'll let the difference be the gymnasts before the new training technique score, and then the score after the new training technique score. And if you'd like to pause for a moment and get this data into the calculator, we're going to put the before scores in L1, and we'll put the after scores in L2, and then we'll step through in L3, putting in L1 minus L2, the difference between those scores. All right, so I put my data in already, and then after your data is in, let's take care of the differences. So once you have L1, L2, what I'm going to do is arrow up and highlight L3. So at the bottom, L3 equals nothing there yet. So we're going to enter L1. So second 1, L1, minus second 2, L2, hit enter. And it will populate that column with the differences. So we could have done that ourselves just by subtracting here, but showing you how you can get those values from the calculator. So you would not have to necessarily write these values down. We're doing it so you can see what's happening here, but you do have them stored on your calculator. So just going through there and writing those differences. And then we'll be running a t-test, but first let's get our hypotheses going. All right, so what we're going to ask ourselves is, if the claim is true, if the technique raises gymnasts' scores, then we have to think about the difference, what should happen. So if the new training technique increases scores, we expect their score after the new training to be the higher score, meaning before training, that would be their lower score. So the difference, when you have a lower number minus higher number, for example, my gymnast A, 9.6 is lower than 9.7, that difference is always negative. So on average, if the technique raises scores, then the population mean of the differences we would expect to be negative. So for matched pairs, you have to give a little thought to your hypotheses, more so than previous sections. So negative means a value less than 0. So the claim is that the population mean of the differences is a number less than 0. And then the null hypothesis always gets equality. So our mu naught will be 0, the mu in the null hypothesis. And then we run a t-test, a regular t-test on the differences. So in my case, the differences are in L3, but you could have also entered those differences anywhere that you would like, as long as you know where those values are stored on your calculator. So let's go to our t-test. So stat tests, regular t-test. You want to switch yourself to data, mu naught 0. And then the list for me is not L1, it's L3. So just make sure you tell the calculator where the differences are. Frequency always stays 1. We're doing a left tail test, mu less than the mu naught number. And then, as always, you can do calculate or draw. I'll do calculate here. And we will write down that p-value. All right, so the TI 8384 test that applies. I know I already wrote that, but I'm going to write it again. So it's a t-test, and we always do a t-test for matched pairs. And then that p-value is pretty big, 0.2064. And I like to write that as a percent. And then we compare that to alpha, the significance level. And up top, they said to do a 1% significance level. So that p-value is certainly bigger than 1%. So the p-value is not low. Do not let the null go. So we do not reject our null hypothesis H0. So based on a sample of these 1, 2, 3, 4, 5, 6, 7. So at least based on a sample of these 7 gymnasts, if we do not reject the null, there is not enough evidence to support the claim that this new training technique will increase scores on average. All right, so in the next one, I'm going to go ahead and put the differences in L1. So just to show you, you have some options here. So I'm just going to go back to my lists, and I'm just going to clear out my list so I have a better screen going for you. And then we'll take a look at number 4. All right, so we have a physician claims that a person's diastolic blood pressure can be lowered if, instead of taking a drug, the person meditates each evening. So 10 subjects are randomly selected to participate in a study and are pre-tested. Their blood pressure is measured in millimeters of mercury before their meditation practice. And then the 10 patients are instructed in basic meditation and told to practice each evening for a month. And at the end of the month, their blood pressure is taken again. So our matched pairs are listed, and we will test the claim. So my claim is that meditation can reduce blood pressure, and we'll use a 0.01 significance level. So this time the significance level is given in decimal, which is fine. And let's check it out. So D will be the difference of they'll take their before blood pressure, their after blood pressure, and subtract. So if the claim is true, if meditation does reduce blood pressure, so that would mean after they meditate, we would see their blood pressure go down. So if the claim is true, their blood pressure will be lower after the meditation practice, making it higher before their meditation practice. And a higher number minus a lower number always results in a positive number. So if meditation reduces blood pressure on average, then the population mean of the differences will be positive. So positive numbers are numbers greater than 0. So we have our claim, the population mean of the differences greater than 0. Null hypothesis is equality. Mu naught 0. Oops, sorry about that. Mu naught 0. We do a regular t-test on the differences, D. So rather than entering all that data in L1 and all that data in L2, I'm just going to write down the differences because this is pretty simple here. So 85 minus 82. So that's 3, and then 6, 0. 83 minus 75. I'm going to be super lazy with my brain and just let the calculator do it. So that's 8. And that one is 6. And that one, 11. And now the next person, they had a blood pressure of 79 before meditating, but after their value was higher. So that's why now you're getting the negative difference. All right, everybody else seemed to have blood pressure here. That went down. All right, so on my calculator, I can just put those values into L1. You can actually put them anywhere that you would like, but I will do L1. And I think the typo is up there. All right, so our differences here, 3, 6, 0, 8, 6, 11, negative 3, 10, 4, and 16. And then when I do my t-test data, now I do have to switch back to L1 there. That's where I put my differences. This one is a right tail test. And I'm going to go calculate again. You can always do draw. And that is a very small p-value, 0.0034. So that's not even 1%. That's less than 1%, 0.34%. So a very small p-value. We'll compare it to alpha. And alpha up there was 0.01. I again just like to think percents. So 1% again. So 0.34% is less than alpha. And technically we do less than or equal to there. If our p-value is less than or equal to alpha, so p-value low, let the null go. Sorry, my pen is being weird, but you can read that hopefully. Reject H0. So based on a sample of these 10, I don't know if they call them patients, people, I'll just call them, it says patients. So based on a sample of 10 patients, so when we reject the null, there is evidence to support the claim that a practice of meditation reduces blood pressure on average. All right, and there you go. That's how you're going to handle matched pair examples.